This class is all about introducing you to Kubernetes, everything from using it, which we'll get to later in this class, to right now, the understanding the nomenclature. So when we throw around words like nodes and pods and services, you have a little bit of an understanding of what those mean before we dive deeper into each one of those in the future. Before we dive headfirst into Kubernetes, I think it would be best to quickly cover some of the names and concepts at a high level. That way, when I say something like a pod, you don't immediately think I mean a place to take a nap, although a nap would be nice right now. Be warned, I don't expect you to understand or know all of these things, and I don't expect them to make sense just now. I just thought it would be really helpful for you to have some idea about what they mean before you hear them, and sometimes explaining one piece of this requires me to use the nomenclatures of others that we haven't learned just yet. Kubernetes has a few core concepts, tools, and services. And these are pods, replica sets, deployments, namespaces, services, kubectl, custom resource definitions, Kubernetes control planes, nodes, kubelets, and that's about it. Now, before we talk about these, let me clear something up. A lot of these are Kubernetes resources. A Kubernetes resource is just a simple resource that can be managed by the command line using declarative files. We'll talk more on declarative versus imperative in the next lesson, but I wanted to kind of let you give a little understanding right now. You don't usually, and I would probably say it's never really recommended to create pods or containers directly with Kubernetes. But instead, you're going to want to describe, usually using a file, how many and of what type container you want to run. And then Kubernetes is going to work to make sure that you have those, that these resources, these pods are running how you want. This is the declarative state. You declare what you want. Let's start with pods. A pod is really what Kubernetes actually orchestrates, not containers. Most people think Kubernetes is a container orchestrator, but it is not, and there is a huge difference as to what a pod versus a container orchestrator would look like. It's a pod orchestrator. This being said, a pod is a collection of one or more tightly coupled containers. These containers can and do communicate with each other like they were running on the same host, aka via the local host, and share the same storage. We'll delve further into running and managing pods, but this is the base concept that Kubernetes manages. Remember, while pods can run with multiple containers, I would say in general, in the 95% case, it is bad practice for a pod to run more than one container, but they can and they do run more than one container. Replica sets and deployments are used mostly to work together and work to achieve a singular goal of managing deployments of pods. We'll get into more of this on later as we have a whole lesson on this and why there are both deployments and replica sets, but suffice to say that these, especially deployments, are what are used by Kubernetes to manage pods. You almost never want to manage pods directly. You use these higher level controllers, and controllers is another term you'll learn more about, to do so for you on your behalf. A pod is not that smart itself, and deployment brings all the functionality you expect from Kubernetes. Controllers are things that take your declarative resources, like a deployment, that contains all of the logic needed to ensure it's running. Think of it as a control loop that knows how to do a certain job. This is the backbone of Kubernetes, is these controllers that have control loops that monitor the resources and ensure that they're updated for your declarative file. Namespaces are a tool used to separate and isolate resources in your Kubernetes clusters. These can be used for a lot of things, But for right now, all you really need to know is that there are two main ones when you start a new cluster. The kube system is where all the Kubernetes system components run, and the default namespace where things go if you don't specify one. In general, the default namespace should only ever be used for playing around and probably never be used in production. Services are the type of resources used to expose your deployments and pods in Kubernetes. This maps the traffic to wherever your pods are currently running. If you think about it, the entire goal of Kubernetes is to make it so you don't have to care about where exactly your process is running. Kubernetes can handle the container, machine, nodes, and faults. But to do this, if a node was to fail, Kubernetes might schedule your pod on a new machine. But you wouldn't know that, and you wouldn't know where that machine was. This being said, you don't need to know where your pod is running, and the service handles mapping all of this network traffic and all these requests to your pod for you. Nodes is a term that's used a lot. These are your machines that Kubernetes is actually running on and where they will run your containers. These could be bare metal. They could also be VMs themselves if you're running in cloud providers. These can even be containers themselves, though this is not a production way to run. A Kubernetes node is just an instance where the kubelet is running, and the Kubernetes can schedule containers to run on it. This brings us to kubectl. It comes under many names: kubectl, kubectl, or the Kubernetes CLI. It is the primary command line tool used to interact with the Kubernetes control plane. kubeadm is another tool that you should know about and is the default open source installer supported and maintained by SIG Cluster Lifecycle to create Kubernetes clusters, and is really the driving force behind how Kubernetes clusters run, and is a really cool project. CRDs are custom resource definitions. These let you implement your own Kubernetes objects like the ones mentioned above. So when we talk about a deployment, that's a built-in resource definition. And you can build your own custom resource definitions for things that Kubernetes might not know about. This is a much more advanced topic and will not really be covered more in depth till much later on, but I wanted to make sure you knew what that term was in case you heard it thrown around. The Kubernetes control plane is where the API servers live, as well as the guts of Kubernetes. The control plane is where the real magic of Kubernetes happens. But usually, the Kubernetes control plane does not run any of the containers on it and delegates this task out to things we call worker nodes. The kubelet is the service that runs on each of the worker nodes and manages the pods and containers currently running on it. It's the service that interacts with the container runtime and reports back to the control plane on all of their statuses. That was some of the basic concepts and some of the not so basic resources and tools that you can interact with in Kubernetes. There are many more, but those are the ones that you're going to learn more in depth on in this class. Understand that all of these resources can and do have their state described in YAML or JSON files, and all of them are used to manage, deploy, scale, and secure your service or application or container running inside of Kubernetes. To summarize all of this that we just covered, deployments and replica sets manage pods that manage containers on a given node. Services expose these pods. Namespaces separate your pod to give teams separation, while CRDs or custom resource definitions are just a way people can implement their own resources and explain them to Kubernetes. kubectl is the command line tool we will going to be super heavily using and that you're going to get very familiar with in the near future. To interact with the Kubernetes API server that runs on the Kubernetes control plane to create, update, delete any one of the aforementioned resources. So I know that probably a lot of that still does not make sense, and that's okay. My hope is that in the future, you will be predisposed to some of the items, and the puzzle pieces I laid out today will start to fit together as we dig into each one of those. If I have not scared you off by now, join me in the next lesson to better understand immutable infrastructure and declarative methodologies. I want to thank you for joining me today for this lesson. If you liked it, please like and subscribe to this channel and support me in making more lessons on computer science and Kubernetes for you guys.